In this series, we're going to showcase collaborations where Delta partners with nonprofits to develop data-driven solutions for social impact. Today, we'll present our partnership with the Center for Climate Analysis to build a geoanalytic solution that detects criminal deforestation in the Amazon rainforest. So let me cover the agenda for today. So today we'll be going over the mission of the teams behind this collaboration. We'll be talking about the project scope and deliverables. We'll give a live demo of the solution. We'll dive into the solution's technology and architecture. And finally, we'll be going through the impact on the Center for Climate Crime Analysis mission to combat criminal deforestation. First, I'd like Sean McPherson to cover Delta Analytics mission and impact. Sean is the Senior Director of Fellowship Programs at Delta.
Thanks, Jeff. Yeah, Delta Analytics started around 10 years ago when data scientists from the Bay Area noticed the power of data in their day-to-day occupations, and they wanted to find a way to harness this data for social good. And so Delta Analytics' mission is to address the data skill gap that many nonprofits face, help these organizations make data-driven decisions, and implement strategies that help maximize their social impact. Since 2013, Delta Analytics has completed over 80 projects with nonprofits and social impact organizations. Additionally, we've curated an open source curriculum and taught in person around the world. We've recruited over 300 professionals who have volunteered their time developing data for good resources and consulting for nonprofits. In all, we've donated over 28,000 hours and charged zero for our services. And I'll hand it over to Jonathan to talk a little bit about the project team that was working on this project.
Yeah, thanks, Sean. So there were a total of 6 of us who helped on this project. Me, Claire Costello, Karen Trunker, Vibhuti Bhatt, Lakshmi Jadwasi, and Swapnil. And I'll be here today to present our project. So as a proper introduction to Center for Climate Crime Analysis, I'm going to pass it on to one of the directors of data analytics, Haran.
Thanks so much, Jonathan. The Center for Climate Crime Analysis, or CCCA, is an NGO organization from the Netherlands, and the mission is fight against the climate crime in the world. The CCCA has many different projects in different parts of the world, and now you have a project in the Amazon, and in the Amazon use the data and law for investigate these environment crimes and support public governments and other NGOs for fight against deforestation. More part of deforestation have a relationship with the livestock because this project is so important for us. In this project, you had a participation of the 3 people, me, Rodolfo Gadelha, and Diele Monteiro, for develop the methodology, develop the idea of the analysis, and work together with Delta for generate these tools. Now I pass again for Jonathan, please.
Yeah, okay. I'm going to be going over the scope of work. So exactly how we implemented this, and I guess a better visual understanding of the main problem. Actually, first of all, let's just go over the main idea. So on the left, you can see a snippet of our final deliverable, which is a map of year-over-year changes of farm properties that have moved specifically to avoid deforested areas. So on the left, I know it's kind of hard to see, but we have the 2024 year-over-year changes checked off, where in blue, you see the lighter blue, you can see 2023 year farm registries that changed to specifically avoid deforested areas. The brown polygons are the deforested areas, and you can see at the right at the upper right of the 2023 light blue polygon, it intersects with it. There's some overlap. And in 2024, if you click on the darker blue polygon, you can see it moved specifically to avoid that deforestation. And we know that's the same polygon due to the, and I know it's hard to see, but the COD Imovell field, which is the unique ID of each farm cadastre that the Brazilian government has in one of their databases. And you can also see things such as like the distance, so how many meters it changed year over year. And on the right, you can see a summary table of these statistics. So for each year pair, you can see the number of total cadastres. And cadastres is basically the registered property of a farm. You can see it increase year over year. And you can also see the total amount that have been moved specifically to avoid deforested areas. So you can see it's at its highest in the most recent year of 2024 to 2025. You can also see this percentage of total that have moved over the total cadastres and the average distance that have changed, which are roughly around 25,000 meters. And we'll show like the map itself in a bit after we go through the scope of work and how we implemented this solution. So it's your standard data pipeline. First, data ingestion from the prods and CCCA data from their respective APIs. Prods is the deforestation API, where we get the deforestation data, and CCCA is the cadastre data, or I think the abbreviation is CAR for cadastral, rural, something in Portuguese, which I can't say, but that's the shorthand for it. And then we pre-process the data, we validate it for correct geometries to make sure there's no corrupted geometries. And geometries, again, are these polygons that you see here. I'll be getting into more of that later. And then we also standardize the data to make sure they have similar column names to make our data processing easier. Secondly, we data process using PostgreSQL, more specifically PostGIS, which is an extension of Postgres specifically for geospatial analysis. And within data processing, we do three main things. One is find the previous year cadastres that intersect with deforested areas. So going back to our visualization, that light blue one where it intersects on the upper right of it, and we join it with the current year. So here it's 2023, and we join it with 2024, and we join it with the specific unique ID, which is COD Imovell. And then afterwards, we calculate the distance change year over year to see how far exactly did it change. After getting this necessary data from data processing, we serve it on Martin and MapLibre. So these are just two tools that help us see these polygons on a map efficiently and clearly and very fast. So there's like almost very low latency compared to other solutions that we tried out. Okay, so let's move forward to the demo. I'll show you guys exactly what it looks like. So let me share my screen. All right. So this is basically what the final solution looks like. We tried to replicate it to look at like official Brazilian government maps as well. But on the brown, these brown polygons, you can see it's the prods data or the deforested areas. And they have been filtered mainly for the Amazon rainforest and also only those that actually intersect with properties year over year. So let me show an example. So if I click 2025, you can see in purple the ones that change from 2024 to 2025. Let's take this one, for example. It intersects, as you can clearly see, with the lighter color, which is 2024. I can click on it to confirm. The actual year comes from 2024. Here's the unique ID and the distance changed. And once I click on one, you can see a line that basically tells you exactly where it changed to, which is this much smaller polygon here. You can see the actual year is 2025. That has the same unique ID and distance. So yeah, it's good to showcase these because some of these just don't make sense. Given a farmer who has registered their property on the Brazilian government database in 2024 basically mapped their farm to look like this, and now it looks like this the next year. It doesn't make sense, and like Haran said, we suspect that it's because, well, they get fined and penalized if their farm registry intersects with deforested data, and this is their way of avoiding these fines and penalties. And if we click on any of the other ones, such as this one, it'll have the same exact functionality. And here it's like a really small portion of deforested data, but again, you can see it moved to this much smaller farm registry. And again, like some of these don't make sense. Like in the earlier year, it's so much bigger than how it looked in the next year. And it also falls upon this stream here, and which is interesting because it's a farm registry. Sometimes, most of the times, they don't intersect with streams such as this. And this functionality extends to year over year, or a bunch of different years, such as this. You can see they all show up in their own respective colors. If I click on them, you can see it goes again to the next year and how they intersect with the deforested areas. There's another functionality where we made it so that CCCA, or Center for Climate Analysis, when they use this tool, if they have a specific ID in mind and they want to search for it, they can use a search function. And this should, okay, great, it didn't work in the demo, but now it works. It should zoom to the specific ID. So you can see in the earlier year, it intersects here with the deforested area, and it automatically shows you the line where it moves to the next year. And it works for basically all of them year over year. If you want to see it for other years, again, like this doesn't make sense. Like, how is a farm cadastre in the middle of a river? So hopefully this tool helps pinpoint specific IDs of cadastres that have moved in this way that doesn't really make sense. Great. So this is the basically the final solution to our project. So let me stop sharing and go back to our slides. Moving forward, actually, sorry, I actually missed a portion. I do want to show the code that I have very quickly. And we basically use a mix of, again, you saw from the scope of work, Python, PostGIS, and MapLibre. And we do all this from Docker. We try to make this as seamless as possible so that CCCA can use and adjust our project really seamlessly. And we do that by using make commands. So let's say you pull this repository or you clone this repository, which you can find when you click on this header up here, and you just cloned it. And we have a bunch of make files and commands to help you set up this project. One command to actually get these services running that I mentioned, the PostgreSQL database and MapLibre, the data visualization tool, is by just running these make commands like make start. And it'll automatically run the Docker containers that you need, which are isolated environments for these tools. And you can see that when they're started and the locally where they're hosted. To actually load the data, again, it's another make command, which is make load data here. Based on the data that you have available, it will run all the analysis and it will give you basically how long it took for each year. And again, this is the Python part where we load the data onto PostGIS. You can see how long it takes, how many records there are, and a summary of loading it onto PostGIS. And after that, if you want to process the data on PostGIS, you run make analyze, which runs everything within the PostGIS Docker container. You can see a summary of each year. So here from 2020 to 2021, it took 17 seconds. All the cadastres that moved to no longer intersect the deforestation data, and a final summary table that prints out based on all the year pairs you have locally. And lastly, if you just run the make web dev, it will have a local port open on your localhost to look at this map and analyze your data. All this is ran locally, and because it's all individualized in their own Docker containers, we made it easier. So if you were to host on the cloud instead, it'd be much easier because there's a lot of different container tools to do exactly this, such as AWS's Elastic Container Service. Yeah, and also putting it on the cloud, you don't have to run this analysis every single time. Once you run this make analyze function, you have all the pre-process analyzed data within PostGIS, and then you push that container onto the cloud. And from there on, you never have to run the load data or analyze again, unless you want to for the next year, but you don't have to run these processing scripts again. Okay, great. So that's our final technical demonstration, and let me go back to our slides. If I can just find it 1 second. Okay. Again, here's a system design diagram that is hopefully easier to follow, where we ingest data with Python, we load it on PostGIS, we serve it on Martin, and we use MapLibre and a mix of MapLibre and React to have it as our front end. The fast API on the right is basically the search function. So if we were to look up a specific ID, it calls that data from PostGIS and gives you the correct geometry you're looking for. I can go more into Martin and MapLibre, but basically it just makes it easier to see thousands of polygons on our map. And once you have everything running through the Docker containers, these are how they all communicate with each other through their respective ports locally. Okay, so I'm going to pass it back to Haran for impact of our final project.
Thanks, Jonathan. These tools have a big potential of impact for fight against the deforestation in the Amazon. These cadasters, these farms in these cadasters, is a principal system for monitoring, for companies monitoring the suppliers have or not deforestation. And these companies have an agreement with the Brazilian prosecutor for don't buy production, don't buy animals from the areas of the have a new deforestation, especially illegal deforestation. But the problem, it's impossible now in the public system identify each farms had a modification in the limits of the farms and avoid deforestation. With these tools, it's possible now companies and the government see if the farmers modified the limit of the farm for avoid deforestation and block this kind of farm because it's like a fraud. And with this, avoid productions, animals from deforestation go to the companies and after go to the Europe, the United States. This is so important. In this moment, the prosecutors use this kind of analysis for a new criteria for the companies analyze before buy production from the suppliers. And these tools have a big potential for avoid this kind of things. Other important things, these tools now is totally connected with the public systems and can get the data in real time. This is so important for avoid problems with the modification of the data when past the time. And now it's possible to see in real time the modifications and the kind of frauds. These kind of things can help government and companies for avoid production from deforestation go to the Brazil and Europe and the United States.
Yeah, thank you for explaining that. And that wraps up our presentation. We hope you guys enjoyed, and let us know if you have any questions in the chat.
Yeah. Thank you, Heron. That's the potential for global good with your solution. It's very exciting. So we look forward to seeing how you're putting this to use and how this can help you in the future. I don't think we have questions yet, but I did have a couple questions. Haran, could maybe you talk about how this data is used by the prosecutors to do investigations?
Yes, in this moment, you passed this data from the NPF, and now NPF have many investigation in specific case. But the idea is use this system in the future for more public access and for many of the government and the companies access this system, and it can use this system for avoid by production from illegal deforestation, production from illegal deforestation. MPF is a prosecutor, Brazilian prosecutor office. MPF have a big interest in using this kind of tools for monitoring this kind of fraud and avoid this problem in the beef chain.
Excellent. I had another question too. Maybe one of the slides that Jonathan showed, it looked like there was an increase year over year in the distance change for the Cardassians. And I thought, is that some kind of trend that's worth understanding why there's a distance change? See, it goes from 22K up to 31K.
Yeah, honestly, that's a good point. And I haven't done exact analysis for this question, but I'm assuming because deforested areas are increasing year over year, so you have less room to move, I guess, closer from your original farm area. You would have to move farther out since deforestation areas are increasing.
Uh,
That's my assumption.
so it's getting more difficult to do criminal deforestation, I guess, and get
Yeah,
away with it. Yeah,
yeah.
yeah, very good.
Okay, I see two questions in the chat. One from Brahmani, which is what was the most difficult part of the project? 100% the front end. I am not a front end person. I'm a back end person. I'm like a data person. That search functionality you guys saw, I put hours into it, and it's like super simple, but I've never done it before. And React is a beast of itself. So that was the most difficult part. And another question from Jay, the tech side. What was the most? Oh, same thing. It was the most difficult thing to implement, and are there other tools to consider refactoring? Um, I'm not sure about refactoring, but I think a lot of things are going to change once you push this onto the cloud. Like what exactly you want to keep. For example, like the pre-processing and loading onto PostGIS. That'll probably change once you push it on the cloud. Um, and Martin and MapLibre are pretty necessary. Let me go more into about Martin actually. This was actually a difficult thing about the project. So usually, traditionally, when you have a bunch of polygons on a map like this, it all loads at once and your browser kind of holds that all into memory. What Martin helps us do is instead of just connecting the data source and like basically loading it all into your browser, instead you connect Martin as like a layer on top of your database. And once you zoom in and out, it'll call the correct polygons based on what you're looking at. So it's dynamically fetching the data from your database. It's not just loading everything to memory. And that's what makes this solution very like a lot more seamless than our current one, our previous one, which was using Leaflet. And Leaflet basically loaded everything into your browser's memory, and it was slow and it took a while for the polygons to show up.
Jonathan,
Yeah.
one thing is important. Say these tools is unique tools in Brazil have this kind of information. In general, the other tools use just the cadastre and deforestation, but never showed the modification in the time. This is the first time you develop this kind of tools for analyze the modifications in the time and cross this information with the deforestation. The government now is working for develop the tools similar, but now is the first, the unique tools in the Amazon. And I think it's possible in the future export this idea for other place, for all the counts in Latin American, Colombia, Peru, and other Amazon counts. For Africa, for example, like Congo and counts in the Asia is possible too. This idea it's so important. It can be used in the other place.
Yeah, that's awesome to hear. I know me and Haran, we talked about how he's planning to utilize this tool for policymakers, and I hope this, like he said, it goes really like a long way, and it can really go. How I envision it is it can tell you more about the economic impact of well, where this illegal cattling is going to, like which conglomerates are they being served to, which meat markets are they being served to, what's the economic impact at the end of the day. And I really hope like this goes a long way and like showcases these different things as well. All right. Any other questions?
Yeah, I'm not seeing any currently.
Yeah, we can wrap it up then. If
So yeah, Jonathan and Haran, that is very good. Very excellent work you guys did. You should be proud of this work. And hopefully, like you said, other organizations could use this in the future too.
yeah, hopefully. I think it just needs to, like the biggest hurdle is like pushing it onto the cloud, and you just go on a website and just see it automatically.
Right.
And we want to like eventually. Yeah, let me share my screen real quick. We want to eventually have like statistics on here too when we open this, like how much have they changed year over year, have maybe like a bar graph where you can see the changes year over year about like distances, how many they overlapped with, things like that. And hopefully we abstract all that technical jargon and stuff that I talked about and instead have like a download data button for like year over year and just make it more user friendly for yeah, basically everybody, like for any non-technical person.
Other important things about these tools is in the next few months you'll be happening the COP in Brazil. It's so important to show this kind of tools. It's a solution for monitoring deforestation, monitoring the forest, and avoid production from the illegal areas. These topics. It's so important for the show for the world is the possible solution like this one.
Yeah, yeah.
Sounds good. Thanks, Haran. Okay, well, I think we can wrap up. So thanks, everyone. Good presentation.
Yeah, thanks for listening, everyone. I hope you enjoyed. And thank you, Haran, for staying with us throughout these 3 months. And I hope this goes a long way again.
Thanks so much.